This is the first of 3 examples of how to sketch a slope field that I will walk you through. This first one we're going to look at is the differential equation dy dx equals x plus 1. Now remember, a slope field is a picture of the slopes at infinitely many points in the plane. And each one of these dots you see, this is what a typical slope field graph looks like. The dots are simply there as a reference, and it's through each dot that you are going to draw your little slope cut. So each one of those dots represents a point in the plane. To generate our slope field, all we do is simply substitute into our differential equation the chosen point. Now this differential equation depends only upon the x value. So what that means is, as we sketch our slope field, you're going to notice that everywhere the x values are the same, those slope cuts are all going to be parallel to each other. And we're going to make use of that fact as we draw our slope field. I'm going to start over at the far left at x equals -3. If x were to equal -3, that means we have a dy dx, a slope of -2. What that means is at every one of these dots over where x equals -3, I need to draw a little slope cut that has a slope of -2. And we're going to go back to your middle school and Algebra 1 days to do this. You're going to want to have some sort of straight edge to do this. I make use of a little 6-inch ruler. What I would recommend for you, though, is use of your graphing calculator lid and perhaps the straight edge right along there or along here. Seems kind of silly, but the reason is the day of the AP exam, you are not permitted to bring in a ruler to the exam room. So you, of course, will have your graphing calculator with you, so you could use the lid to serve as your straight edge. So back to our problem. We were using the x value of -3, and we determined that the slope there needs to be -2. I'm going to start up here at this point in the upper left. What I need to do is line up my straight edge. So if I'm going through this point and I need to have a slope of -2, that's down 2 and to the right 1, so I'm going to align it with this point right here on the x-axis. And I just draw myself a little slope cut. Notice it's just a little bitty line. It's not a really big line. It's just a little slope. Now remember, we talked about that everywhere there where x equals -3, all of the slopes are -2. And I mentioned we're going to make use of the fact that these slope cuts over at x equals -3, all are going to be parallel to each other. Once you get this first one drawn, simply slide your straight edge and draw your next slope cut through the next point. And you can just keep doing that all the way down. You just want to be careful when you slide it to make sure they're parallel to each other. Now we go to the next x value, x equals -2. Substituting into our differential equation, we get a slope of -1. Once again, I'm going to start up here, and I need to line up my straight edge so I have a slope of -1. So that's down 1 and to the right 1. So I'll line it up with this one over here. And yet again, since I know these are all parallel to each other, I'm simply going to slide my straight edge to generate all those other slope cuts. One thing you'll notice when we get to x equals -1 is that when we substitute in, we get 0. This is one of the points you definitely want to look for on any type of slope field that you need to draw, where it is that you're going to have a slope of 0, therefore having horizontal slope cuts. That's often a place that we'll start when we draw our slope field. So these are all really easy. These are all just little bitty horizontal lines. Once we get to x equals 0, we start having slope cuts that are positively sloped. So when x equals 0, we have a slope of 1. I'm going to start up here at the top, and I can think of this as down 1 and to the left 1. So I'll line it up over here, and there's my slope cut. And once again, I'm just going to slide it, being careful to keep them all parallel. When x equals 1, we have a slope of 2. So starting here, I can think of that as down 2 and to the left 1. So I'll line it up over here. And once again, I'll just slide these down to generate all my other slope cuts. When x equals 2, I now have a slope of 3. So that's down 1, 2, 3, and to the left 1. And finally, at the far right, when x equals 3, we have a slope of 4. Starting once again at the top, I have to go down 1, 2, 3, 4, to the left 1. And that's what our slope field looks like. The great thing about these, remember that you have that slope field graphing calculator program. You can easily put this differential equation under y1, and you can run the program and make sure that yours looks like as it should. If you start thinking ahead, eventually we're going to be drawing solution curves through these. Well, if you were to think about taking the antiderivative of this differential equation, we know that's going to be x squared over 2 plus x plus c. Well, x squared over 2, that means we have a parabola. And take a look at what happens. Notice here where we had our horizontal slope cuts, that becomes the vertex on our parabola. So we know our parabola is going to go upward, because if we did the antiderivative of this, again, we'd have x squared over 2 plus x plus c. So we know it has to be a parabola that faces upward, and the minimum, the vertex, is going to be here somewhere, in the plane. How high it sits depends upon your c value, but definitely it's at x equals -1 that we know that parabola is going to have its vertex.